Hello, I am Shubham Ahire, and today I am going to explain about our project hand gesture recognizing musical instrument, that is Theremin, using implemented using Arduino board. This is how real Theremin look like. Outline of our PPT is system overview, design consideration, architecture strategy, system architecture, detailed system design, GUI design, invention detail. In invention detail, you will see object of the invention, brief description of the drawing, working examples, and implementation. In implementation, you will see flow diagram. So, system overview of our project. The Theremin is based on a simple LC oscillator built around a 7400 quad NAND gate IC, a wire antenna, and a few clips and registers. When a hand moves closer to the antenna, the frequency of the oscillator increases. When a hand moves away, the frequency decreases. On the software side, the oscillator is connected to the internal hardware counter of the Arduino. Every time there is change in the voltage output by the oscillator, the counter increases by the 1. This counter is tallied up over 1/10th of a second, and the distance from the instrumentalist to the theremin can be determined. From there, it is just outputting a frequency to a speaker. So hardware requirements: Arduino ultrasonic ranger, SR05 and SR004, breadboard, connecting wires, battery, and speaker. Software requirement: to write code on Arduino board is Arduino IDE. Version of software is 1.8.5. So detailed system design of our project is: this is the hand of the performer, and this is the antenna. The antenna is connected to the LC oscillation circuit. So if a performer moves his hand near to this antenna, it creates a virtual capacitance. Due to this virtual capacitance, there is change in frequency of a sound. When the performer moves hand toward the antenna, the frequency increases, and when the performer moves away his hand from antenna, the frequency decreases. So this is how a theremin works.
Hello, I'm gonna explain how the graphical user interface design of this Theremin project which we are using to find the gesture motions of the hand. This is the Arduino. This helps to combine the whole circuit. This is the ultrasonic ranger, which is used to calculate the distance between the hand and the antenna to vary the oscillations. This is the amplifier, which is used to amplify the audio output, and this is the potentiometer to vary the frequency and filter out the unwanted frequencies from it, and amplifier is used to amplify the frequencies which we want to output it, and speaker will output the audio according to it. We can change the volume according using the potentiometer if you want. This is the invention details. We are trying to implement a Theremin using an Arduino with a variable pitch system, which will use the volume as the output. The initial goal of the Theremin more accessible to everybody, like for the common people, a user interface to help use Theremin for common people. It is also used for the hand gestures. We can change the music according if you want to using the hand gestures. It takes the predefined data sets to find what the hand gesture mean. We can use the machine learning algorithms for it. This is the basic flow chart of the Theremin, how it works. Reference oscillator is the minimum frequency we have to set for the output. Variable oscillations are like you can increase and decrease the frequency of and tune to clear out the unwanted frequencies. Mixer will add both frequencies, and amplify will amplify the output signal we want, and speaker will output it. These are the different references we took from net. Official Arduino site for learning the Arduino code. Arduino code book by Michael Margolis. Code vendor to come use the Arduino with the hardware thing. That's it. Thank you.
Created here is a theremin, which is a musical instrument which does not require any physical contact when it is being used. It only works on the concept of I have a sensor and an antenna here. So the closer I move my hand towards the sensor, the louder the noise it's going to make. And there are basically two sensors. So the other one sensor controls the how loud the note is, and the other sensor controls how loud the frequency is, how high the frequency is. So what we have implemented here is a basic Arduino circuit, which consists of an Arduino Uno board, a breadboard, a SRF04 ultrasonic ranger, a speaker, different wires, and uh, an audio amplifier. So first, what I have done here is I have attached the ultrasonic ranger to the breadboard. Then I have given an a 5 volt supply from the Arduino to the ultrasonic ranger, uh, which connects over here, and this is going to the ultrasonic ranger. Now there are two other pins in this ranger, trigger and echo pin. They are connected to the digital 11, 12 and 13 pins of this Arduino board, and I have this buzzer here, uh, which is taking input from the Arduino same, and the speaker wire is connected parallelly to the digital pin 6 of Arduino, which gives a one output if it detects uh, how close my hand is. So if we have set a limit of 30 centimeters, so if my hand is within that 30 centimeters, then the speaker generates an output, otherwise it does not generate an output. So now I'm going to show you the working of this Arduino. Okay, now I'm going to demonstrate how this project works. Yeah. So basically, what the project should do is the ultrasonic ranger here should detect if my hand is 30 centimeters or closer uh, than the sensor. So if it is, then the buzzer should generate a sound. Otherwise, it should not. So this is the basic concept how a theremin works. So we take how close the hand is uh, from the sensor, put it in an tune circuit, LC circuit, and then that generates a particular tone. So now I'm going to show, put my hand 30 centimeters or closer. So you can see that the buzzer is making a sound, and as I fade away, the sound generally fades away itself. So this is how this project works. Thank you. Classically, a theremin makes use of an LC circuit, which there are two types of oscillation circuits in my theremin. One is the variable oscillator, which is a LC circuit, and the other one is the reference oscillator. When we combine the input from these two, we get beats, and that leads to sound. But and that is the same principle applied when I move my hand closer and away from this sensor. It generates a sound with different pitches. If my hand is closer, the pitch is loud. Otherwise, the pitch fades away gradually. So due to some incompatibility issues with the hardware, we were not able to incorporate an LC circuit. But classically, theremin should use an LC circuit, which generates sound and which leads to music.